Hey guys, sorry I couldn't be there today. Again, my son is going to be homesick, so I have to stay and watch him. And we still need to get some of this stuff done, so I figured I'd make you a video explaining the types of problems in this next section. This is the last section in the chapter 9. This is 9.6. I think it's straightforward enough that I could work out a problem here with you, show you, what it looks like, and let you try a few on your own. I think, we can get by without me being there today to at least get this started. So we're talking about solving systems of nonlinear equations. Oof. So first of all, what does it mean to solve a system? Solving a system is, a system is two equations at once, right? Two equations at once. And if we're solving a system, we're really looking for the points of intersection. You might be saying, wait, we did this earlier in the year. We did. We solved systems of equations, linear equations, where we had two lines, we graphed them, and we said that the point of intersection was the solution. So what's different today? Well, the equations we're solving today are nonlinear. Specifically, we're going to have one linear and one quadratic. So what's that going to look like? Well, if I have a linear function, it's going to be a straight line. And if I have a quadratic function, it's going to be a parabola. So think about what the solutions are going to look like. In this case, I have two points of intersection. So I would end up having two solutions. Now, it's possible to have a system of quadratic and linear that has one solution that would look, it's a parabola and a line that would look something like that. Here's one solution. Or it's possible to have a parabola and a line that don't cross at all. So you could have no solutions. Should kind of sound familiar, right? This is how quadratic equations in general can be solved. When we find the roots of a quadratic function, we're looking for its x-intercepts. And we know that in finding x-intercepts, we could have two of them, one of them, or none of them. So a lot of this should sound similar. So how's this a problem like in this section going to look? I'll give you a linear equation, a quadratic equation. We're going to use algebra to find the solutions. And then we'll check our answer on Desmos, of course, so we can, make sure we did it correctly. Some problems in your book have you solving by graphing. We're not going to do that. The only way we're going to solve these types of problems is using what I'm about to show you right now. So, are you ready? Let's do it. Here's an example. I have a linear equation and a quadratic equation. So two equations together makes a system. If I'm trying to solve the system, I'm looking for where the linear and the quadratic intersect. And remember, it could be any one of those three possibilities on the right there. So how do we do the math? How do we find the solution? Sorry, I'm writing on things. How do I get rid of that? There. We solve it by taking the first equation, which has y by itself, and setting it equal to the second equation, which also has y by itself. So if we just set those two equal to each other, we'll get an equation with just x's, and then we can use one of our methods for solving a quadratic equation to get the answers. So I'm going to set those guys equal to each other. That's going to look like x squared minus 13x plus 7 equals negative 3x minus 2. And just by looking at this, remember we had those problems with the four options, 4 methods available. So you think about it, it's not going to use square roots, probably not going to complete the square, looks a little complicated. So I'll probably set it to 0 and try zippy, if not quadratic formula. So I'll set it to 0 by adding 3x and adding 2, both sides. And on the left side, I get x squared minus 10x, combining those terms, plus 9 equals 0. And that looks like a good zippy problem to me. If I play the x game, looks like 9 and negative 10. Think about it, what are the two numbers there? Negative 9, negative 1, nice. So your factors, x minus 9, x minus 1 equals 0. So we get two solutions here. X is positive 9 and positive 1. So the key here, again, is that we're setting the two equations equal to each other. They both have y by themselves. So we're taking thing 1 and setting it equal to thing 2. And that's how I get a quadratic equation with just x's that I can solve. So now what? Well, for each of those points, I'm going to need the y-coordinate. Remember, I'm looking for like an ordered pair, an x, y, for each point of intersection. So if I take a look at the x equals 9, if I plug in x equals 9 into either one of the two equations I started with, let's choose the simpler one, the linear one. I'm going to put 9 in for x. So here's the linear equation I started with. That's this guy is what I'm referring to. I'm going to put 9 in for x. And that looks like negative 29. Negative 9 times 3 is negative 27, minus 2, negative 29. So a solution would be positive 9 for x and negative 29 for y. That's one of my solutions. Then I'll take my second x value, which is 1, and plug that into my either one of the equations on the top. Again, I'll plug it into the simpler one, the linear equation. Negative 3x minus 2. Plug in 1. And that looks like y equals negative 5. So another solution. The x value was 1. The y value was negative 5. Sweet. So that's the kind of problem I'm going to ask you to solve today. Again, it's a system, one linear, one quadratic. They both have y by themselves. If they don't, you can move stuff around and make sure y is by itself first, and then set them equal to each other. This is the substitution method you remember from earlier in the year. And when we set them equal to each other, we get to this step. And then we solve. This is regular quadratic equation stuff in the middle. And then we're plugging in each of those x values to the original to get the y. Let's check that on Desmos, if I can do that here. Let me try to get this to work. So all I'm going to do on Desmos to check my answer is plug in the two equations I was given at the beginning. So I have a linear function and then a quadratic function. That's not plus 3x, it's minus 13x. Sorry, that looks sloppy. There we go. So this here on the left is a minus 13x. And if I move around my zoom, I can see the parabola and the line cross twice, and then I can just click on the points of intersection, and there they are, 1, negative 5, and 9, negative 29. So use this as a sample for doing the homework problems, and I hope to be back on Tuesday. Hopefully my son is doing better and everyone else here stays healthy. And sorry I had to miss class again today, guys. Do the best you can. Thanks.